Also, I think, oh, cool, thank you. If I don't reply in the chat because all the windows, the Zoom windows go missing, please just voice it as Savita did. Any questions or thoughts? So nice to here. So the function calls itself. It needs a way to move forward, right? I think that people call the official term is the inductive step. I'm actually going to put that in parentheses. I think the way that I will describe it is like, have a means to progress. Towards the base case. Cool. What happens if we don't have a means to progress towards the base case?
An overflow.
A Stack Overflow, right? One of our all-time best websites for developers to find answers, basically. That's where their name comes from. And you can think of it, this, we can actually compare it to a lot of, in terms of like if for loops, for instance. Let me remove a little bit of zoom here. So we can say, we also said you could also, everything that you could do with that recursion, you could do with a loop. And so, let me bring this here. And here, let's talk about what this will be. In a loop, the base case will be the condition. If we compare recursion to a loop, we have the condition, let's say like for let I equals 0, while I is less than the array length. I plus plus. Right, so when will this loop stop? When this condition is no longer true. Right, so in recursion is a loop. It's a different kind of loop, but it's for doing repetitive tasks, just like a loop is for doing a repetitive task. And this is the terminating condition. Like once this condition is false, it stops being true, then the loop will stop. The means for progression in the loop is the increment here. And we're gonna need to have that in our recursion as well. A means of progressing towards the base case. And here you could say the same thing. Oops, I think I'm getting some background noise. Here you can say the same thing. We are progressing in this case on the array. The way we're progressing that is we're starting at 0, so we have a start point. We progress by adding 1 to this 0 to I until I is no longer less than array that length. I'm using an H here. Cool. So what other things about, so I guess let's put here a few other concepts. One that we talked about is like the call stack. But what other surrounding concepts around or thoughts, ideas you have about recursion? Okay, so let's do this. Why don't we, let's take 5 minutes, each one of you, write a recursive function that does something. And then let's talk about that. Just have this in mind. Have you have a base case. It's going to be a conditional with an if statement. Have the function call itself, and try to come up with a progress step, an inductive step, that to move towards that base case. Let's try that for 5 minutes. Just open up REPL. Try to have a function that has these three things. And let's talk about this. You share, and we can talk about what you came up with. Cool. Okay, so let's do 5 minutes from now. So 19:07:41. In the meantime, I'm gonna make some space here in my board. Just try to write a recursive function. It doesn't have to work. It doesn't have to do anything, but try to have these 30 things in. Okay, so why don't we share what you came up with in the chat here? Let's take a look. Cool. So we got one by Douglas. Let's take a look.
Nothing too complex, like you said.
Mm-hmm. Cool. So let's analyze this code and let's see if it meets our criteria for recursion. So we said, or actually, anyone wants to point out from the three components that we talked about the recursion, which ones does this one have and which ones doesn't have?
It doesn't have a base case.
Okay. Actually, let's list here the base case, call to itself, and means of progression. Oh, this is interesting. Cool. So Jonathan says it doesn't have a base case. Give me a thumbs up if you agree with that. Give me a thumbs up here in the, well, I guess it can be in the participants tab. I see one. So only one. What does the rest of you think?
We got two wrong.
I had thought that it reaching 100 was the base case, if I understand what base case is.
Right. So I think this has a base case in the sense that you have this condition here, and we said like base cases are generally conditionals, right? If statements basically, or control flow statements. Now, so this has like, you know, the base case is also, you can think of it also as like as a stopping condition, like when is it going to stop? And we do have that. We have this. We have something that will make it stop at some point. Now, how about a call to itself? Owen, what do you think? Do you think this function has that part? And maybe, so the question is this function calling itself?
No, it's not.
Okay. What would it, can you give me an example of how would this function call itself?
It would put count to 100, and then inside the, oh wait, actually, wouldn't you need a you need like a parameter, right? So it would need to be like count to 100 with the parameter like -1 or something like that.
But let's not think about the parameter yet. Like, how do I have this function call itself?
With a return.
You put the function in at the bottom under the bracket or while.
Like what line?
Oh, line in between 7 and 8.
So like here. So if I call the function here, something like that, right?
Oh no, actually, you should put it in the while statement.
Oh, inside. Like here. So, right. So for this example, like I guess the point I want to make is that the function, this function, count to 100 is not calling itself, so it can't be called recursive. because that's one of the main parts of a function being recursive, that it calls itself. But actually, this gives us a good example for the recursive function. Right, so we could have this function call itself anywhere.
Okay.
So let's try like here. Let's see what we get if we run this. Run this here. It seems that maybe it froze, and and my computer stopped working. So actually, what I'm gonna do is I can't even select text. But what's going on here is the function is calling itself indefinitely, right? So we call count to 100 here on line 11. Count to 100, then does the while loop. Once it finishes the while loop, it's gonna call itself again. Then another while loop starts, and so on and so forth. And we can see here that I got this page unresponsive. Let's try to exit. Let's try to refresh this and see what we get. Cool. So actually, I think this might be, yeah, I'm gonna actually save it for later, so we can see the call stack getting filled basically. Okay, so then we don't have doesn't meet the criteria for call itself. Do you guys hear that? Like a dog crying. And it had a conditional that will have a base that will tell us where to stop, but it didn't call itself. Did it have a means of progression? Well, from the point of view of the while loop, it has a means of progression. It has a counter where it starts and it's going to keep going one by one, adding to that counter. So, like these things by itself wouldn't define recursion, but is the inner living of them that makes recursion. I think from those, that's why I put this one as the first one. I think the first one is being the most important, a function that calls itself. Cool. So if we want to fix this function to let's say count to n. Let's call this function count to n. Right? And I want to pass in here 10. And I want this function to count to 10. How do we do that? Remembering that we want the function to call itself. Let's change that a little bit. Let's say I want to count down from n. I want to count down from n. And what I want to see in the console log basically is 9, 8, 7, and so on and so forth till we get to 0. How could we have this function call itself and go down from 10 to 0? So let's think about here. Actually, let's start here. I'm gonna receive n here, and we do countdown from n. So we need a base case. For this example, think of the base case as our stopping condition. When do we want our function to stop? Joanne, what do you think?
Once it reaches 0.
Once it reaches 0, right? Like we don't want it to go to -1, -2, right? We don't want this, guys. So once it reaches 0. So could you help me, Joanne, write a condition here for that?
You could write if n is greater than or equal to 0,
Greater than or equal to 0. Okay.
then
Right. Let's leave it here. We have a condition. If n is greater than or equal to 0. So if n is greater than or equal to 0, somebody else, what do we want to do?
Couldn't we console log n and then take away from n?
Console log n and take away from n. Actually, so yeah, so I realized that it had flipped. We sort of flipped the coin in my head, and I didn't realize. Here, so this will still work. In fact, maybe we can come back to that. But let's think about the base condition as when do we want it to stop? Here is like we don't want it to stop when n is greater than or equal to 0. Right? Let's say we want it to stop. It will work because it's sort of the two sides of the same coin. And maybe we can see that. So let's say when n is equal to 0, we want it to stop.
So we'll console log n and return n.
Let's console log n and let's return. Let's not return anything. Just return to stop.
Right.
Cool. So we have our base. We have our base case. The base case is generally the first thing that you write in your recursion. So we have our base case. Now, how about a call to itself? Let's call it itself here. And so we have a call to itself, but we need this next part, a means of progression to get to the base case. So basically to get to 0. Any thoughts for that? Douglas.
I don't know if you want to do an else if or just simply just a new if statement altogether, but the I would imagine if n is greater than 0, console log n n minus 1, and then fire countdown from n and push n through it again.
Yeah, let's try this. So something like this, if I'm correct. I don't know why my works. Something like this.
Yeah, I think that's where it needs to be. No, well, so fire it there.
Let's think about this. So when we don't really need this if statement, because we know. Oh, okay. If it's greater than 0. Okay, let's do the if statement for now. So when we pass in 10, right, on the first call, n is not 0, so it's not going to go here. It's going to go here. And 10 is greater than 0. We're going to console log n. And then it's going to take 1 away from n. And then it's going to call countdown from n with what? What is n now?
That would be 9 in there.
That would be 9. And then the whole cycle just repeats itself. Imagining it now, n is what is coming here through this shuttle, or I don't know how to, through the argument. Now is 9, n now is 9. And then n is not 0. N9 is greater than 0. Yes, console log n, take 1 away from n, and then call countdown from n, where n now is 8. So does that sound like maybe it will work? Like it will go, it's gonna come down from n to 0? Give me a thumbs up if you think it's gonna work. Okay, I see 1, 2, 3, 4. Cool. 5. Yes, great. Thank you. So we have a majority there. Let's take a look. Let's run this. And we have a recursive function. Yay. From 10 to 0. Where did you guys go?
Is that undefined part of like REPL, or is that something we need to account for?
Yeah, so this undefined is just the return value of this. And it's just that REPL just shows you the return value of the last thing you typed. Just so that, yeah, because it's helpful sometimes. But yeah, this is not coming sort of explicitly from our code. Yeah. Cool, so we have here the 3 parts, right? We have the base case, which is when to stop. And we just stop by returning. We have this other case, which we actually don't need. Or there's some edge cases that we can talk about, but let's remove that for now. Let's see if I can format document. Yes. Let's just make sure that it still works. Yep. So we don't need that other part. Here, our base case, we do the work. We subtract 1 from n, we call it. So what is our means of progression, I guess, here? How do you describe that?
The n plus plus? I mean the n minus minus?
Mm-hmm. So that's one part. And what is like the next thing?
Call to itself?
A call to itself with the new n, right? Or with the subtractor or the progress n, we can say, right? Yeah, like calls to itself with the progress n. And this is something very common in recursion, where the function just modifies its original input, reducing it to something or leading it to something else. Like in this case, where we start with 10 and we just start reducing that on down to 0. Questions or thoughts about this?
I think I spy where that edge case might be.
Mm-hmm. Tell us. Yep, share it with us.
Which is, if you pass a negative number into this function, it'll just count down forever.
Correct. This plus minus 7. Oh, and then this, I'm going to copy this just for safety measures. Let's run. Oh, we got something. Nice. At least it stopped at some point. But yeah, you can see that it's going down to minus 9,000, 10,000. And let's see the error. Maximum call stack size exceeded. In other words, a stack overflow. You filled up the stack. And we can see then, this also sort of tell us a little bit about how big the stack is. You can put about 11,380 functions in the call stack. We try to put one more, and then it didn't have more capacity for that. So this is revealing a little bit of the internals of how big our stack is. Cool. So how do we account for this case then?
Would you do greater than or equal to 0?
Yep. Let's take account into the base case. Less than or equal to 0. So when it's less than or equal to 0.
Less than.
Right. Let's do less than then. No.
No, greater than. I don't know.
Let's think about this. If we wanted to stop when n is less than 0. or when it reaches 0, this is the same thing. Yeah, and we can see, let's try this out. Right, so it console log 7 because minus 7 is less than 0 and it returned. Let's say we don't want a console log actually here. We just want it to exit. Just want it to exit. And now we get nothing, right? Nothing is being console log because our value is negative. Now let's try 10 again. And we get our series. So generally this, your base cases are generally small, something like this. Basically, if n is less than 0, just return, don't do anything. We're not interested in that. We want it to stop. In other words, and also, so that's sort of taking care of the edge case, but it's also taking care of when to stop. We want to stop as soon as n is not is. We want to stop as soon as n goes below 0. Right. So this is first we were thinking of like the base case in like when do we want it to stop. Now our base case is still doing that, but it's also sort of taking into account that edge case that if it's negative, we also want it to stop. So almost sort of like doing double service basically. Okay, so this is good. The way in which we will generally do this, like this minus minus I wouldn't do it here. Generally because you don't want to modify the inputs. You want to, generally for pure functions, for instance, you don't want your functions to modify your input. You generally want to make a copy of the input and modify the copy, or yeah, actually that's most of the that is what you want to do. Make a copy of the input. Never modify the input directly or as possible. So the way that I would do this is, instead of this is modifying n that came here, what I will do is just do n minus 1 here. I'll remove that here. So n minus 1, what it does, it doesn't modify n. What it does is subtracts 1 from n, and it passes that new number, which is 9, down to the function. And let's see that will still work exactly the same. Cool. So I'm no longer modifying n, because n minus minus, what it's doing is overriding n with n minus 1, overriding n, and we don't want to override our inputs unless you really know what you're doing. And then we do that here. We just compute the new value, we pass that as our new n for the next call. Cool. Give me a thumbs up if this is making sense. Cool. Great, thank you. I see your thumbs up. Thanks for your participation. So now I'm gonna show you this. I'm gonna show you the call stack in Node. So I'm gonna copy this. Open up VS Code. Visual Studio Code. And this will also help you. I think it will be a little bit different for debugging like your backends. We're supposed to use we're not supposed to use as much console log. Like we should use the debugger much more. I think I do tend to use the console log much more. I don't. It's been very few times. Actually, for me, the console log gets me through most bugs. Only when I have to track something very deeply, I use the debugger. And let me show you how to use that here. So I'm going to create this here. Let's put this big. Let's save this here as Recursion 1.js. Is this easier? Is that easy to read? Is it too small? The color is good?
It's done.
Cool. Okay, so I call my function, my file recursion1. Actually, I think I'm gonna have to create a folder. So let me just go to my desktop and put this in a folder. Stop recursion. Let's move recursion. Recursion1, which is in my home folder. Let's move it to the recursion review folder. And let's just open. Okay, so we have this. Now for debugging, what you can do is, I have this appearance activity bar. I removed this because I don't use it as much. But if you go here, there is this play button with the bug. You can click on that, and then you do run and debug. Oh, actually, this is cool. Now they improved that. I think we no longer need to do any setup. Let's try this. So what I need to put is a breakpoint. Where do I want it to stop? So I'm gonna ask it to stop here, and I put that red dot there. As you hover over here, you're gonna see that. Now let's run and debug. Oh, this is cool. Now you don't have to do any setup. Before there was a little bit of setup you needed to do. Cool. So now my function is stop right here. We can hover over stuff, I think, and see what n is. So we can see that n is 10. The call stack, we can see the call stack here. There is only one function into the call stack. And there is some other internal stuff, but for our purposes, only one countdown from n. This is our call stack. I think we're gonna see other functions being added there. So I'm gonna release it. I'm gonna let it go by 1. It's about to be called. Now we see that n changed now that we're on the second call, n now is 9, as we can see here. And we can see the second call here on the call stack as well. Let me put this here. I don't know, can we do, oh yeah, this is awesome. This has improved quite a lot. We can see the values n on the first call. As I click on the first call here, and the second call is 9. And then if I just keep going, you're gonna see how the call stack gets filled here. We can see n, how it's changing. N is 3, n is 2. So you see the call stack is being filled with calls to the same function. And none of these functions have finished because, well, they're calling itself. So the call with n10 calls itself with 9, and so on and so forth. N right now is 2 as I keep stepping forward. Now n is 1. And the next one, n is 0. Actually, and then from here, we're going to see, let's go here. So right now, we have how many calls in the stack? How many calls do we have in the stack?
1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Is that 11?
That will be, well, it will be 11 because of this one, the initial one we call. Cool, now we see that n is 0, and I'm gonna step, so with this button here, the step over button, you can sort of skip over to the next time. With this button, step into, you can go sort of inside. So I think I'm gonna hit this one, and you see that like now we're in the call when countdown was invoked with n minus 1, and we're gonna see that then as I step into, we fell into this if statement. We return, and let's take a look at what's gonna happen with the call stack from there. So n is minus 1, we return, then the previous function finish. now the function that where n was 0 is about to finish. And we see the call stack going back. So like down in a way, until then we finish here. And our call was count down from 10, and then the call stack is empty. We finish our work basically. And you know, this is here. Let's do. Oh, actually, before we jump into that, any questions about this? What we saw and how to replicate it?
Mm-mm.
Cool.
Question.
Yep. Yes, Joanne.
Why are you calling it twice again? I don't know if you mentioned it before.
What do you mean calling it twice? Where?
Before the end of the function and at the end of the function. So the you're calling the function twice, and
Right. So this function is one of those, right?
mm-hmm.
This function call is just to get the recursion started. And then this is the call to itself that is inside of countdown so that it calls itself. So that's, yeah, the first one is just to start, to get it going for the first time. And then after it just goes calling itself. Mm-hmm. Does that answer your question?
Yeah, it does.
Cool. Actually, I'm gonna change my color theme because I can't see the line numbers. It's this one. Yeah. Cool. So and you saw the call stack go up, and the last call on the stack was the call with 0, or actually, the call with -1 went in, and then from there it went back down, right? That explains why if we do this, console logging before and console logging after the recursive call gives us an interesting result. Let's take a look at this. So I'm gonna open terminal. I don't remember how to put the terminal on this. Does anyone know how to put the terminal on the side? No, I don't remember exactly, but we can do it here. I'm gonna do node recursion 1. We'll get this interesting result. What do we see here?
It's decreasing and then increasing again.
Uh-huh. It's decreasing and then increasing again. This is
Alejo, could you scroll down a little bit on your
on the code.
Yeah, in the code.
Let me know if this is too small. So let's do this. This is when the call stack is going up. This is when the call stack is going down.
Hmm?
So any sort of thoughts about this? We can break it down.
Oh, we had mentioned.
Is it a double negative sort of thing where it hits, like after it does its 0 and you're hitting it with like -1 minus 1 is 2 kind of thing?
Wait, -1 minus 1 is 2? No, it's not doing that.
Oh, okay.
Giselle, you were gonna say something.
Yeah, so in the beginning when we were reviewing and all giving our thoughts, we had mentioned that recursion involves a call stack. So as we're going through the recursion list the first time, it's going through the stack. And then once it's done with that, it kind of like pops off, I guess, the stack. I don't know very well, but that's why it goes and does what it's supposed to do first, which is go from 10 to 0, and then once it's done with that, it basically like throws them back up. I don't, again, I don't know how to say it, but it goes back up to the original number. So that's why it goes like in the stack and then out the stack.
So yes, let's try to see what Giselle is talking about. So I'm gonna console out the first, I'm gonna comment out the first console log. I'm gonna run this again. And we see like, now it seems like the numbers are going up. It's starting at 0, going to 10. The recursion is still going down. It's just where the console logs we have. And so let's think about, so what Giselle said, like at some point the call in the call stack gets popped off because the function finished, because the function returned. So let's take a look here again at the call stack. So let's put a console log like here. Let's put a breakpoint there, and let's run. So, and then I'm gonna open here the output. So currently we're in M10. That's the first call in the call stack here. On the left, N is 10. And I'm gonna go. So you see the next line that will run is when countdown from N gets called with 9 now, because N minus 1 is 9. So I'm gonna keep going. And you see that put another call on the call stack. It put another call on this call stack where now N is 9, right? And are we console logging? Where is the output? Terminal problems, debug console here. We got our 10. Shit, let's restart this because I was not putting on the name. So the first N is 10. So we console log 10, and that does this up 10. And then we're gonna call countdown from N, passing N minus 1, which will be 9. And as I step into that, we see that there's another call added to the call stack with value of 9. And then we are in this line, then 9 will be console logged down here. 9 is console logged, and so on. So we see that the console logs, none of those functions has ever reached line 8 because it's calling itself. None of those previous calls have reached line 8 because the call stack is being filled in. So we see all of that. Now let's see what happens around here. So we have N0, right? And for none of these previous calls, that line 8 ran because this recursive is calling itself. And those recursive calls, none of them has finished. So let's go in the next call, I think. Did I click correctly? Let's see. Oh, okay. So wait, let me try to redo this here, because I think 1, then 0, and then I want to try to step in. So when N is 0, we get this here. This will return. This will quit the function. The function that we have at the top of our call stack is right now, because we're executing the one that with N minus 1 is that one. The one below that is with N0. We can see, we can even see, you see this green line highlighted here? That is where that function is, sort of waiting for the recursive call that it made to finish. So you could think of it as at each step, the other functions that get put into the stack are waiting for the recursive call to finish at some point. And here it's about to finish because we are at the top of the stack, we have -1, N minus 1, and that is gonna make it finish because it's gonna return. So as I go there, return, what's gonna happen here is that that function gets popped off the stack and we go back to the previous function, right? And the previous function is N, has N0. So, and we're gonna see, pay close attention to the lines that are gonna be highlighted here. So we're about to return, we return Actually, it hasn't returned yet. N is still -1. We return there, and note that we went back to N, to the previous call, which is N0. This is because the call for N-1, where N was -1, finished. And we went back to the previous call, the one we had sort of left off, where N is 0. And now look at how the line we're going to execute is line 8. Now for the first time, we are reaching line 8 because in the past we were sort of stuck in the loop, the function call in itself. Now at this point, it's sort of we go back to this context. At this point, N was 0. So what is this line going to console log here? 0, right? So let's go in console log 0 because that's the call stack. The function call in the stack at this point has N0. Now, once that is done, the function will return undefined. Actually, we can even see it here. This has improved quite a bit. It returns undefined because we finish everything in our function and we don't have an explicit return. It returns undefined. That causes it to finish. And what's going to happen is we're going to go to the previous call that we had in the stack, which was where N was 1. And we can keep going. And now it's sort of, this was, I think, when we first saw recursion, the way that I talked about is like the stack going up and down. Now we're seeing it coming down. And then you could also think of as the recursion, with each recursion call, the variables for that recursion, for the current recursion call, are preserved. So we still have, somewhere, we still have the N5 because those functions haven't finished. And each one of these N's is being kept because the function has not finished. Somewhere in memory is being kept. But anyway, now we're on N1. That one finishes. Then that gets popped off the stack. We go back to N when N was 2. We console log 2. That gets popped off. We go to the previous one where N was 3. And N3 gets console logged. That function gets popped off the stack, and so on and so forth. So how does that feel? A bit better with the call stack?
Thank you for showing that. I do feel a lot stronger on that now.
I'm glad. Any questions, thoughts about this? Okay. Let's see. Cool. So this is a very simple example of a recursive function. I'm thinking. Let me take a look at the DSA. Let's take a look here. Recursion. I think I had some examples that I would like you guys to do. Okay. Cool. Okay. here, can we take this example, and I want you to try this. Actually, I'm gonna pair you up. Can we write this function? Iterate recursive. It is recursive. What this is gonna do is it's going to take in an array and an index. What this function should do is console log log all elements of the array. Log all the elements of the array. And then the way that I will call this function is something like iterate recursive, and I'm gonna pass in I'm gonna pass in, well, actually, let me think this exercise a bit through. Yeah, actually, let's remove that, and let's just have array. And I want 2, 3, 4. And what I want to see in the screen is there's elements being logged individually like that. So let's try this in pairs. Let's see how it goes, and then we can review it. Iterate recursively on this array. So let me share this in here. Oh, I guess now the code I will share here, is this code being kept? So yeah, I guess now I'm gonna share this on the code share channel. And then, so I'm gonna pair you up. You can go in your pair and talk about how you would approach this, thinking of the recursion that we saw above. So let me see. Actually, Sergio, you will go into. Just I thought they had added the option to create breakout rooms in the middle. I guess then we're not gonna be able to do this. I guess the pairs that I made. Oh, and I think you should be in a breakout room. Let's take 5 minutes. Actually, let's take 7 minutes to do this. So if you, I guess in here, then what we're gonna need to do is the people that is remaining here, we're going to work, I guess, as a as a whole in trying to work through this. Let me, let's start discussing how we could accomplish this. I shared the code in the code share channel. I'm gonna go announce the time to the other breakout rooms, and I'll be back.
Thank you.
My original was kind of like this. And what I did was like, but I don't think it made sense because I did like an if statement.
Hello.
Hi.
I just wanted to say that we have about like 7 minutes. Let's do 10 minutes.
Can you send out like a little notification when there's like 1 minute left?
Say that again?
Can you send out like a little notification that, you know, counts it down? It's like, hey, we're gonna break up.
Gotcha. Yep. See you in a bit.
Start a screen share. All right. And if I could just dump that there. Oh, that.
Hello.
Hey, Sergio just went to get food. I think he went to order food. I mean, he ordered food and he's going to get it downstairs.
Okay. Do you think that this is gonna be quick or?
Yeah, he's just picking it up and coming right back.
Okay. Cool. So we're gonna take about like 10 minutes to work on this.
Cool.
Okay. I'll see you guys in a bit. Hopefully he comes back soon.
Isn't a while loop like using a for loop?
Hello.
Okay, what's up, Alejo?
I just wanted to make you guys aware. We're gonna spend about 10 minutes on this and then we join back in the main session.
Okay.
Cool. See you guys in a bit.
Choose some stuff. Oops, I may have lost my screen share. I may have frozen. Who knows?
I can see your screen.
Oh, cool. I think we're going to need to. So we have an array coming in, and we need to. Well, obviously, we need to look inside of that array, but we need to. But we're not passing anything else through. So I'm trying to figure out how this can hold on to. For example, my first thought was to do something very similar to what we did before, but that won't work. But the where it's like console log array at index. See, that's just it. We're not getting anything to iterate over.
Any thoughts from Khadija, Jonathan, or Suzette?
I'm trying to figure it out first.
How about what did you think about the base case? When do you want this to stop and not do anything?
Want it to stop when you reach the end of the array.
Okay, we want it to stop when you reach the end of the array. That's correct. What do you want to do for like an empty array if I pass in an empty array?
Oh, you want to check if there's elements in there.
Yeah.
So would that be like one case?
That'll be one case. Mm-hmm.
So like if array dot length equals 0.
Mm-hmm. I'll be back real quick.
Oh, well, I think I got it, but it would alter the array that we're getting. And that is, so we've got this to catch for the moment. Yeah, an array can never have a negative thing. So if that happens there, that's fine. Otherwise, what you need to do is console.log. Oh, actually, no, it wouldn't be, it can't be 0 because 0 is an index. No, length is different. I'm sorry, that's, yeah, never mind. Console log array at index 0, right? And then array dot pop. No, I'm doing that the wrong way around. Array dot unshift.
For each.
Do it for each.
You can. It turns an array into numbers. But I don't know if that's really recursive.
Yeah. Shift and then recursive array. I mean, we're still altering. Oh, actually, you know what? We just do it like you did before. Maybe we can do something like do that, like pass that as a.
This is cool.
That way we're not. That feels a bit better. So that we're not directly altering the original array, I guess.
Mm-hmm.
Actually, you know what? I'm gonna. Well, maybe I should
So
pull
what was the thought behind the array on shift?
Maybe I couldn't remember I was trying to remember what knocked something off the front of the array. So that way we're going from left to right was my thinking. So if I'm always console logging the array at index 0 while something exists within the array, it's going to, unshift would shrink the array. It would knock the first 0 would become index 1 of the original array, and until there was nothing left in the array.
Mm-hmm. That's fundamentally how this algorithm was going to work. Yeah.
So
you want to share? Cool.
Oh, do you want to, Jonathan? Do you have it on your screen? I can stop sharing.
Yeah.
Okay. Let me stop. Hold on. There we go. It's all yours.
Can everybody see it?
Mm-hmm.
Yeah.
I mean, I got to undefine at the end of it, but that's what I have.
So walk us through.
I put I at 0. I mean, I really don't need to put I at 0, but I assigned the incoming array to a variable, and I was checking to see if the array.length is equal to 0, and then I returned it. But before I returned, I console logged the array at index I. So since that condition was never true to begin with, we start off at array at index 0, which is I, and then I would shift the first one off and then call the array. And from right here down, we get 1, 2, 3, and 4.
Mm-hmm.
I think I need to go through the code a little more, because the last thing I have is undefined array, but for the most part.
Yeah, this is great, actually. Does anyone know why it's getting undefined? Or anyone else has questions or finds this still confusing? That'll be fine. Douglas, does this make sense to you?
It does. I'd actually, when seeing Jonathan's implementation, I immediately realized that much like push with the U, unshift is the same way, and it hit me like a ton of bricks. Mm-hmm. But I'm just trying to is it I don't know if is that undefined something we actually. Oh, is it because it's console logging array at I, and when there's nothing in there, there's nothing there to console log?
Right, when the array length is 0, that means the array is empty.
Yeah, that was my question too.
Cool. Khadija, does this make sense?
Yeah, it makes sense.
Cool. What does this have? Oh, let me call on the rest. What does this have in common with, what similarities do you find between the previous example? This and the previous example.
Wait, we were talking shit about something. What was it? Oh, people's parents.
I don't want to. Oh, I am unmuted. Much like the first one, we are we're not altering the original input.
So that actually, that one is not true, but we can talk about it. But what else? How, from the fundamental, it might sound like a trick question, but fundamentally, how is this still recursive? And maybe some step that you notice that is different, but still is the same in terms of what it is, and then in terms of the three main components of recursion, but here we're doing differently.
Don't we have the base case, the means to progress, and then the callback?
No.
Right. So great that you restated those three. So we still have the same things, right? What is the base case here?
If the array length is relatively equal to 0, then we just return.
Yeah, I would remove the use of the word relatively, because if it's 0, return, finish, we're done. Right? If it's exactly 0, return. Okay, so we got that. What about Zuzet? What do you think is the means of progression here?
When we use the shift statement for the array, I mean the shift function for the array.
Right, and what does that do?
Take off the first element in the array.
And then, so effectively, what are we doing as a whole with the array then?
We're modifying the array.
That's correct, and we're shrinking the array at each step, right? And that is our means of progression, right? The fact that we're sending something different to each function call until, and remember that the means of progression is progressing towards the base case. By reducing the size of the array, we are progressing towards array.length being equal to 0 at some point and making it finish. Cool. So let me share my screen here, and let's see it. Let's see a few things. Oh, wait, I think, did everyone come back? No, I don't think everyone came back. Oh. Where did the breakout rooms go? I guess I don't know if I can. Oh yeah, I can't jank people out of of breakout rooms. Dump them into the main session. Okay. So what we did here was our base case is if array.length is equal to 0, return. Otherwise, so you did something like this, array, like array copy equal array, and then you did array copy dot unshift, right? And then you did oh, sorry, yes, shift iterate recursive passing the array copy, right? And I guess I forgot to console log. Console log array at index 0. Oh, do you see the colors look weird? Am I missing something? Oh, I think it might be this. Hello. Sorry that I didn't send a warning. So we were talking about the recursive approach, and Jonathan was sharing his approach, which is this one that I have here on the screen, for iterating over the array recursively. So the first thing we have here is a base case, which is if the array length is 0, just return. We don't want to do anything. There's nothing to console log. If the otherwise, we make a copy of the array, not really a copy, I'm gonna say. We try to make a copy of the array, but this is not really making a copy. And then we do console log array at 0. We remove the first element of the array, and we call iterate recursive with the modified copy, which now no longer has the first element of the array, and so on. This is interesting that the syntax highlighting is messed up. Do you guys see that this? Wait, can you see if I zoom in like this? Can you see the difference?
Blue, green, brown.
But do you see that I'm zoomed in?
Mm-hmm.
Yeah, I guess like, yeah, that's weird. Anyway, let's try to run this, see if it works. Let's move this a little bit down here. Let's call node recursion 1. Oh, I guess I should comment this out. Now recursion 1, and we get exactly what we wanted: 1, 2, 3, and 4 console log. Let's take a look at how this works in the call stack, actually. So same thing. Yep.
Alea, before we do that, to make a true copy of the array, would I have to put on line 19 in square brackets the spread operator and then array?
That's correct. Like this. This truly makes a copy of the array, and it's known as a shallow copy. It's known as a shallow copy because if the array has objects inside, this array has just numbers. It's gonna make a copy of those numbers. But if it has objects, if it has anything that is a non-primitive data type, there is no copy being made of those elements themselves. So the objects will still be the same. I think that's a topic that we should review later on in terms of like references and making copies. But yeah, this is how you wanna make a copy of the array. This is how you will do it.
Is that bad for space complexity? Like,
That's
because you're
correct.
making a copy? Yeah.
That will be bad for space complexity, yes. It will be, yeah, and then that will be a trade-off in terms of, yeah, this is bad for space complexity. Here, actually, let's see this point here. Let's do this. I'm gonna console log the array here. I think I'm getting some background noise. Oh, thank you, whoever that was. Iterate recursively. No, actually, I'm gonna console log the array here. And then I'm gonna console log the array after the recursive call. And I think I'm gonna have to close this because this is getting me, this is exacerbating me, the colors. Let me try to avoid. This be fixed. Yeah, okay. So I'm gonna console log the array before the recursive call and after the recursive call. And we're gonna see a few things. Array is not defined, great. Because I never let let's put this here. Just passing the array here. Okay, let's try this. So this is what we get basically. We've console logged the array before the recursive call and we see the array. Then the recursive call happens and we see the console logs happening. And then at the end of the recursive call, our array is empty, which may or may not be what you want. Maybe that that can be seen as a destructive action that function modify its inputs. And that's why I said at the beginning, like, don't modify your inputs unless you really know what you're doing and unless you know that that's okay or that that's what you want. And here, then we end up being that if we try to use an array later on, then the elements are not going to be there because a recursive function is mutating the array, right? And even though you could say, well, this is array copy, isn't it a copy of array? The thing is, with arrays and with objects, oh, I think I got a mosquito in my room. I have to kill it later. With arrays and with objects, basically with non-primitives, what you have is pointers. You have array here. This array here is pointing to a place in memory where the array is. And what we're doing here is, okay, array copy is just going to be a pointer to whatever array is pointing to. So it ends up being something like this. If I go back, maybe here. So somewhere in memory you have the array 1, 2, 3, 4. And array is just a pointer that's pointing to that. Somewhere else you have array copy, which is a pointing to array, which is a pointer pointing to the original array. So these two things are actually just pointing to the same thing, the same array, basically. So, and then that's what we see here, that the array at the end ends up being destroyed, or just emptied, I should say. Let's see what happens if we make a copy of the array here on each iteration. Make a copy with it using the spread operator. We run. Now our array is intact from the moment we passed. We never modified the original array. And again, that might or might not be what you want. Okay, so the means of progression of this recursive function is by, well, we want to get to the array, we want to reduce the array to a length of 0. So we want to be chopping down the array. And the way in which we do that is by shifting, which will remove the first element of the array. and shifting from the copy, and then calling the function again with the array that now has one element less. Cool. Now, any questions regarding this here, how this is working? And we're gonna see it with the debugger, see the call stack, see what we get. With the spread of that really a copy. Yeah, I guess we can leave that copy there. Let's do the debugger here. Let's put the debugger like here. Actually, this should be in the array copy. Doesn't really matter, but everything we're doing is with the array copy here. Let's run this. And we see, well, we saw the first console log, which was this console log in the entire array. Now we see the array is everything 1, 2, 3, and 4. The length is not 0. That's why we skipped this part. We made a copy of the array. We console log the first element, which is 1. And we see 1 being console logged down here. Then it called itself recursively on the next step. It's calling itself. Now we can see, note the call stack, how now we got a new call there. Now we see that the array for the call stack doesn't have 1 anymore because we chopped it up in the previous call. Now 2, 3, and 4. We console log the first element of that, which is 2. Then we remove it. We see the console log here. We remove that 2. We make the recursive call with the chopped down version, which now has 0, 1, and index 0 and 1 with 3 and 4, and so on. We can see the call going up as well. On the last call, right now, array copy still has something. That gets removed. Now here, array copy, since we shifted before, now has length 0, nothing in it. As we go on to the next call, into the call stack, did it ever get called with the empty array? Oh, I forgot to step into, but basically the function finish. And we see our elements console log down here. So the means of progression of this algorithm is by chopping down one element from the array, modifying the array that came in, by removing the first element and calling itself again with that modified copy. And this is something that you will see throughout recursion in general. Now, all these recursions that we're seeing right now is a linear recursion in a way that it just goes. I guess we're gonna get to see it. We do not Fibonacci. Is it Fibonacci? I think it's Fibonacci, where the recursion can also split into 2, for instance. But I want to make sure that this is making sense so far here, how we're doing this recursively. Any questions or thoughts regarding this?
Is this technically making like a brand new array each time it recurses?
That's correct. It's making a brand new array each time it recurses.
Okay.
In fact, we could even, yeah, I mean, we can see it in here. So you see how the call stack is getting filled.
Mm-hmm.
Here at this point, the array is empty. Then we get array 0 length. Array length is 0, and that's gonna make it stop. But in here, this is a cool thing that I didn't know that it was already part of this. If I click on one of the previous calls in the call stack, I can see their context and their variables. And let's say this is the first one, where this is the array and this is the array copy. So this is the array that was passed. The array copy is the same, but minus the first element. We can see that at each one, there is one array copy. So each call has one array copy. Yeah, so at each step, we're making a copy of the array.
But it's not like a stack of copies. It's a single copy that keeps getting overwritten? Or does that not even matter?
It's a stack of copies.
Oh, okay. Thank you.
All these array, like on this function call, when this is the array, yeah, let's do like this one. 2, 3, and 4 is the array copy. That array copy is somewhere in memory. And for this other array copy on the next call, that's another array that's somewhere else in memory. So it is stacked up, yeah. Any questions or thoughts about this approach for iterating over the array recursively? So I hope this also gives a window onto like the idea that anything you can do recursively, you can do with a loop. Iterating over an array is something that we do very often with a loop. We can also do it recursively. I guess before we take a quick break, I wanted to think about another way to do this, iterating recursively. What I was thinking initially was, let me copy this. I'll share this code later on. Was using like an index here. Here, let's iterate over the array, but we'll iterate from the back to the front. So it'll be a bit different. I'm gonna use this index so that I don't have to make a copy of the array. And I can just modify the index, and hopefully we'll see. So I wanna stop when the index is less than 0. So what I'm gonna do is, we're gonna start at the end of the array at index array length -1. And we're gonna be reducing the index and console logging in each step. So we can do this. This can go away. And what we do is console.log array at that index. And then we can say iterate recursively, passing the array plus now index -1. Let's see if this gives us the same result, but in the opposite direction. Oh, we got a bunch of undefined. We got our stack overflow. Oh, I forgot to pass in the initial index. The initial index will be the array.length -1. Not there, but here actually. Oh, anybody got any
I think you
hints?
have to set up default value for the index when you define the
oh yeah, here.
Yeah,
we can do that. We can do that. This should also work though. Index less than or equal to 0. We console the array at that index. We call the array. Wait, I think I hadn't saved actually. Yeah, it was just that I hadn't saved. Let me comment on this. Here. So this is another way. We're console logging, but from the back to the front. And we're not making a copy of the array. What we're doing is just passing in a helper argument, if you want to call it that. And here we just pick where do we want to start. When index to start at the end of the array. We check if the index is less than 0, meaning we finish console logging.
Oh.
we return otherwise. You guys just got here. Owen and Savita.
Yeah, I just realized why it wasn't working for us. We didn't have the index also in the as a parameter. That must be why it wasn't working.
Oh, I mean that was, yep.
No, because we kept getting like array at index 0 was undefined or something.
I see. Got it. We discussed another approach here, which is removing the beginning of the array that you guys can look into. This was just passing an extra argument, an index where to start.
But to avoid passing an extra argument, you can set up a default value, right? That's kind of.
That's correct. So
in this case, the second value comes from the first one. So, right?
So have like an I equals 0 or something like that at the top?
Yeah, if you start from 0, it will be I equals 0. If you start from, can you define it like index equal to array that length minus 1? That will work. I don't know.
This will work.
Pick it up.
We did the I equals 0 at the beginning, but for it kept saying it wasn't defined. I'm trying to look. We have.
Yeah,
so
that was
this should still work as Sergio is suggesting. This is just making use. I don't remember if this is an ES6 feature. But what this is doing is just establishing a default value for the index argument, which is really handy in this use case, for instance, so that I can just iterate recursively with the array. And if I don't pass an index, what happens is that this is going to be used, the array length minus 1. For instance, if I pass in an index here, let's pass in an index 2, what do you think we're going to get in the console log? Anyone? If I pass in the array and I pass index 2, what are we going to get in the console?
The index 2 is going to probably overwrite the original one that you set up.
Is going right. That's correct. We're gonna be using index 2, and we're no longer gonna be using array length minus 1. And what we get is we now are iterating from the second index or index 2. So we're sort of skipping the last element because this is sort of like this, the starting index. We put in 1. We only get the first 2 elements. So yeah, this default values is quite a handy feature. I don't remember if it's ES6. Quick Google search can reveal that. I kind of have the feeling that it's ES6, but maybe not. Where we can define default values in case something is not passed. So if in case I don't pass a starting index to start from, I do this. And I run again, and then array.length minus 1 will be the thing that will be passed, that will be used, because I did not pass an index here. Cool. Oh, what happens here?
It's gonna console log
undefined?
a bunch of undefined, like 96 undefined.
96 undefined. Let's take a look at that. It's 96, and we don't need to count them. The math should compute, and lastly, at the end, we get our numbers. So maybe there's another check we can do here. If index is less than or equal to 0, or index is greater than the array.length. Let's just stop. So in that case, we stop, we don't do anything. Passing 4. Oh, did we get that? We did get undefined index less than or equal. If the index is greater than the array length, greater than or equal to the array length. In that case, we don't get anything. Passing 3. Or we could also do -1. So questions, thoughts about this? The means. What is the mean here for? What are the means for progressing?
The index -1 that's in the callback. I mean, when the function calls itself.
That's correct. So here our means for progression was the index -1, being reducing that index. And here who can remind us here in this approach, which is doing the same thing, it's iterating over the array, but this one is iterating from the front. And what was our means for recursion here? Our means for progression here?
Line 22.
Line 22. These 2 lines basically, right? Where we remove one element we remove an element from the front of the array and we pass in the new array without that first element onto the recursive call, reducing the size of the array at each recursive step. Cool. Any questions about these 2 recursive examples? One like counting down and iterating over an array recursively. Okay, so let's take a 10-minute break. Let's come back at 9:24. Just don't leave the meeting. Just like if you need to go, shut down your video and take a break.
Hey, Alejo.
Hi, Sarita.
Did you see Dessa's invitation, or did she send it yet?
Not sure. Let me take a look.
Sorry if I interrupted you.
No,
I know
that's
that
fine.
we were supposed to meet this evening,
Right.
so I think she's going to meet with us at 10.
Oh, okay.
Talk about how miserable I am. No, I'm kidding. I want to talk about my technical mastery and getting all of that done.
Sure.
Before, because who knows what will happen after June 30th.
Got it.
You did a good job?
Me? Hey, Jonathan. I got the last part of it to work. So if you play the game all the way to the end, it'll tell you that you lost.
Cool. So I can do the CSS now, and we won't have no merge conflicts?
Yeah, absolutely. The last pull request I did, so you can do that. And then yeah, we can make it look like it was not made in 1995.
Oh, so that means you can actually consider yourself a web developer and a programmer.
No, I don't want to give myself that credit. That's no.
All right, fine. If you don't, I will.
I hear Doug talking about like getting videos to work and all of that, and like how fancy his is. So no.
Yeah, listen. Each flower blooms when it's supposed to.
That's a good quote.
I still would like to keep working. I mean, obviously, keep working on it and get the other part of it to work, so that you can't click on cards when you're not supposed to, and the parameters of the rules are written into the functionality of the game. Like whatever cards protect whatever cards. I still want to work on that part of it, and then maybe do a back end and try to move some of this into the back end.
Well, I think the first step will be, before the backend, will be, I guess, optimize, removing the repetition.
Yes.
Yeah, and then from there, then the backend. Because removing that repetition can also clarify how the backend will be. Yeah.
Okay, so Leo, if you have time, right? Since we already have a back end, so to speak, already, can you help me with user authentication? So at least we can get that in before we start moving in functionality.
Yeah, definitely. I'm just thinking, I guess like that'll be after MVP. After MVP, back starting to think after MVP, and some of the repetition has been removed. So maybe like next week basically.
Cool.
I'm sorry to butt in, but Jonathan, Alejo's videos on user authentication are like a really good resource. I'm still watching them to kind of fix the bugs that I have. Really helpful. Like he goes at a good pace. So
the lesson, right, from when he went that weekend, the Saturday and the Sunday.
Yeah, it's in February. It's like February 2nd or 1st, one of those.
Yeah.
I think I can share the link here too. So I don't know if you have some notes, but I keep all the YouTube videos in a playlist organized by like the unit. Let me share that here.
After June 30th, we're still gonna have access to that, right?
Yeah, of course. Everything. Yeah, I mean, our curriculum is all open. And all the videos are going to be there. Slack is going to be there, everything. Let's see, where is that? Channel.
Where did you get this background picture, Alejo, with the animation?
I stole it from a YouTube video.
Oh.
I found like it actually has sound and everything. It's supposed to be like a relaxing sound where it's like it's raining in the picture. You can hear the clock, moving, and you can also hear the fire.
Funny.
Mm-hmm. Oh, I should think that was here. Yeah. So let me share, Jonathan. I'm gonna share here the link to the playlist. Yeah, like watch those videos. Try it on your own, and then you run into trouble or anything that needs clarification, feel free to reach out, and I'll be happy to clarify.
I was definitely gonna attempt to do the back end that way, by following along with that video.
Mm-hmm. My instructors didn't record. I don't think there was just no setup for that. I don't know why. And then on top of that, I almost didn't. I took some notes, but not only sort of keywords. Cool. So I think we're about to get started again. So right now, what we're going to do is we're going to see an example of Factorial. Just because Factorial also show us how can we sort of accumulate the result of the recursive calls. Right now, we're not doing recursive calls. We're not doing anything, or not that they were not doing anything. They were just console logging, but we're not doing anything with the result or the return value of our calls. I'm trying to think maybe about, oh yeah, I guess maybe starting with a simpler example than Factorial, and then moving on to the Factorial one. So let me know once you're all back here with a thumbs up or something in the participants tab. Or just enabling your cameras if you enable your camera. I know you're here.
Nope.
Okay, so I see some thumbs up. Cool. Thank you. Okay, so here is, I guess, let's try this other example. Let me close some of these tabs that I have open. Let's put this here. So yeah, actually, I'm gonna give it to you, and it was just we have almost running out of time too. Yeah, what if we wanted to write a function that adds the numbers here? Let's say const add all nums to n, where we have the passing here. N. What if we want to do this? And when I call add all nums to n, and I pass n 5, I should get, well, 5 plus 4 plus 3 plus 2 plus 1. Is this 15? Five and 5, 15, right? So how could we do this in a recursive function? A function that adds all the numbers to n, to whatever number we pass in. Let's think first about the base case. Who can tell me a base case for this? When do I want it to stop? When do I want it not to do anything?
If number equals target.
We only have n, so you can always only tell me in terms of n.
If n equals 15.
But we don't know. In this case, it will be 15. But if I pass in 6, it should be 16. So
if n equals 0.
If n equals 0 is a better one. Thank you. Let's do that. So if n equals 0, what do we want to do?
Return.
Okay. Now the base case give us an objective that we need to move towards, basically. How do we do that? How do we move on to n equal to 0?
You would subtract n minus 1.
Okay, so we need to subtract. Oh, bye, Ben.
Good night, everybody.
Good night.
See you next week.
See you. Have a good one.
Good night, Ben.
So we want to subtract 1 from n, but we also want to, so we could do this, I guess. Add all nums to n, and maybe n minus 1.
Mm-hmm.
And if you think about it, this is the same stuff we saw here, right? Like that we had here. We can console log it. We can console log n. And let's try this out. So we are console logging the numbers from n to 1. Cool. So we have the numbers, but now we have to put them together. We have to add them together. How could we do that?
Could we use a variable called sum?
Let's use a variable called sum. I like that idea. What do I start this with? Or
we can leave. Can we leave it as a undefined variable, and then on the next line, sum plus equals n?
Sum plus equals n. Like that?
Yeah.
Would this work? Any thoughts? In terms of, so if we leave this undefined and we do undefined plus equal 5, what do we get?
Undefined.
We don't get an undefined, we get a very weird number. What is the weird number we get?
NaN.
The weirdest number of them all, not a number, NaN. So we can't leave some empty. Well, we can see, let's maybe start at 0. And then sum plus equals n.
Then we just console log sum on the next line.
Let's console log sum here and let's see what we get. Still get the same thing. So right now here we have base case, we have a recursive call, and we have a means of progression. But what we need to do is somehow accumulate the result. First we want to, if we break this down, actually this is what we want to do. We want to sum 5 plus 4, and the result of that will be 9. And then what we want to do is sum that 9 plus 3. And the result of that is 12. And 12 plus 2. And the result of that is 14. And we're going to do 14 plus 1. So this is sort of the progression that we want in sum. But here, this is the other part that I wanted to show you, where we basically are going to learn how to accumulate the results. And the way in which we can do that then, or actually any ideas I want to check first, how we could accomplish this. So this is not really doing anything here.
Does the placement matter?
It will not in this particular case.
Okay.
So here, what if, I think, well, actually, any other ideas? So here, let's look at looking at this. We want our function to, so this is n. Let's describe the pattern. This is n, and this plus n minus 1, right? And this result, we want to use it for the next call. So actually, let me just go ahead and do sort of type this, because it's just to see it for the first time. So what if with n is 0, we return 0, right? And we have a result. Let's call it result. Let result. We want to do, let's call n plus, so n is 5 on the first iteration. Let's call n plus plus the return value of add nums to n plus passing n minus 1. So that will be like n plus n minus 1, the result of calling n minus 1. And then here, let's return result. Something like this. This recursion, most people just do it in one line, saying return. Most people just do it like here. Something like this, return. And this will do the trick. I want to save it into a variable just so that we see a little bit more explicitly. So let's do this. And now, first of all, let's see if that works, just to double check. I guess I'm not console logging the final results. Let's console log this. We get 15. Then the question is, how and did we get 15? So this is the recursion now, sort of like the next notch on accumulating the values, building up some results. After we moved on from the basic components of the base case, the inductive step or the means of progression, and the calling itself. The way in which this will work is, but actually before that, any questions, thoughts, explanations that maybe you can provide for this?
Okay, so when we did let result on line 48, right? N is initialized to 5 because that's what we set in for the first time, right?
Correct.
And then 5 minus 1 is equal to 4.
Correct.
But how are we continuously calling add all nums to n? Or
say that one more time, that last part.
How are we still calling the same function if it's in the result? Or is it because we're returning the result that it keeps calling the line 48?
So yeah, this line here is key. We need to return the result. Yeah. I think the confusing part is sort of this side here. So we know that this is gonna be 5, but we don't know what this is gonna be. This is gonna be 4, but we don't know the result of, or the computer doesn't know the result of calling add all nums to n, passing in 4. We'll have to do that recursion. Any other ideas or attempts? Owen? Okay, so let's try to see it here. Let's try to see it here in the debugger, and then maybe I can draw it in the board. So I'm going to put a debugger here on this line. And let's run this. Okay, so what do we have here? Okay, that. Oh, I left a debugger here that I didn't realize. We call we call on the first call, n is 5, as we can see here. There's only one call in the stack, which is the initial call. Then n is 5. And what is add all noms plus n minus 4? Well, we don't know. The computer doesn't know yet because it hasn't computed that. So what happens is we call that, and you see that the next call was put into the call stack, and now n is 4, right? And now n is 4 here. And remember the previous call is still in the stack. It still has its local variables. Everything's still there somewhere in the stack. We call the function with n4, and the computer will do the same thing. Okay, n4 plus add all noms to n, where now n will be 3. And then when we execute that, another call gets added to the call stack. Now n is 3. N is 3 plus all noms to n, where now n is 2 gets called. Now n is 2. Note that we haven't hit the result. There's return line 49 on anyone yet, on any one of those calls. We haven't gotten there. You can think of it as the recursion sort of, well, it's the recursion itself. I was going to say the recursion sort of getting stuck on line 48 because it just keeps going, calling itself. And that's what's going on. It's calling itself, never hits line 48 just yet, until the recursion starts going back up, or the call stack starts going back down. So right now n is 2, and then it's gonna call add all noms n minus 1, which is 1. Now n is 1 on that next call. It's going to add up n, which is 1, plus add all noms to n, passing in 0, n minus 1. Oh, damn it, I wanted to step on that one, but on the last call, before the one that just popped off, was add all noms to n passing in 0. We pass in 0, we hit the base case, we return 0. And we can see that for the first time we go on to line 48. And we can see that n is 1, because the n was 1 in this. We're at the call at the top of the stack, which is with value 1, where n was 1. This part of the recursive call returns 0, because n minus 1 is 0, and then we see that when n is 0, we return 0. So this is n plus 0. This return value is 0, right? So is that clear so far? Okay, so that's 0. So it's 0 plus 1. Now, then this function called finish, and then we're going to return our result, which is 1 plus 0, 1, right? Now, this result will be carried to the previous recursive call as a result of the previous call, which is where this gets confusing. So right now here is this is this call at the top of the stack. Result is 1 because it was 1 plus 0. Now this result will be the result of this for the next call. So let me hit next. We see that the previous call got removed. Now the result is 3, because on this calls that we had in the call stack, n was 2. N was 2, and the previous, do you remember the previous result? What was the previous result?
1 plus 0.
Which is
1.
1. So then this part was 1 plus
2 plus 1 is 3.
And then that's correct, 3. And then, so remember this result. The result now is 3. Once we go to the next one, the n here is 3, right? And the result of this on the previous call, what was the result on the previous call?
Wasn't it 3 on the previous one?
Correct, it was 3. Then we see that the result now is 6. And we keep going, so that result gets carried down. Now here is 4, and is 4. The previous result was 6. Now the result is 10, as we can see here. And we get to the last one where n was 5 at the end of our recursion. This part finished recursing, and that the result of that was 10, as we saw in the previous one. And 10 plus 5, 15, we return the result. So that is sort of here with this visualization. I think the best thing, just to wrap these things up, will be actually if I try to draw it in the board, because there's some limitations here. Let me try to do this here. I'm going to remove this. Increase this size. So you could think of the way that I like to visualize the recursion is, I'm going to call the function just fn. So we do fn of 5. Right? And fn of 5, what we'll do is, it will do, the result is going to be 5, which is the end that we pass, plus fn of n minus 1, which is 4. So this is sort of the way that I think about it. And fn of 4 is the same thing, which is the result of that will be, all this is the result. The result of that will be adding n, which is 4, plus the result of fn n minus 1, which is 4 minus 1, 3. Let me get rid of this part here. And you can think of it as the recursion is, the computer doesn't know what the result of this is, you could think of. And when we do 5 plus the recursion of this, the computer doesn't know what the result of this is. It has to compute it. And for computing that, then it just happens that it needs to do all this other computation, which is the recursive call. And it just keeps going. Then this is 3 plus colon fn 2. And I guess I'm going to need more space. Canvas size. Bottom is that. More pixels. So at any of these steps that we're doing so far, the computer hasn't finished. We haven't reached an end. There has not been a return, right? And we're gonna see when that ends. So what is the result of fn when we pass in 2? What would I type in here? What would I write?
Is it 2 plus function of 1?
Function of 1. That's correct. Thank you, Douglas. And the last one?
1 plus function of 0.
Correct. Now, according to our code, when we pass in 0, what do we return? Take a look at our code.
0.
0.
Return 0. So at this point, then the recursion sort of finished going down. It has to go back up. Or the call stack finished going up, and the call stack has to come back down in terms of height. So at this point, then we know the computer reaches a concrete value, and it reached 0. Then at this point, the recursion starts coming back, which is then the computer knows how much is 1 plus 0. Right? And then this whole thing then becomes what? What is the result of 1 plus 0? 1. So suddenly then the computer knows the result of this part, which is 2 plus the recursive call function 1, which is 1, the result of this is 3. And suddenly the computer knows the result of this part, which is 3 plus the result of function of fn of 2, which we now know that is 3. And we know that the result of this is 5. And I just put it here. 5. And suddenly the computer knows the result of this part here, which is, he knows that the result of this is 5 already. So then he knows how to calculate this, 4 plus 5. The result of that becomes 9. I hope still see that here. Let me move this a bit here. The result of that is 9. Then suddenly the computer knows the result of this, which is 9. Then it can do 5 plus 9. Wait, did I miss something here? And math is not adding up. Wasn't it supposed to give us 15? Uh, 1, 2 plus 1 is
6 instead of 5.
Say that again?
It's 6.
Oh, here. Wait, sorry, where?
Where it says 5.
Here, this is a 6. I think I'm my math skills are very poor. Let's see. This was 3 and 3. That's correct. 6. Thank you very much. Right. This is. I guess I should be writing this here. Because it's 3 plus the result of fn2, which is 3. Then this is 6, and then 9. We end up with 15 here. Any questions, thoughts about this? Was this helpful at all?
Very.
No, this did clear. I'm glad it stuck around. This helped me out a lot.
Cool. I'm glad. I think that's the main point. So questions, thoughts about this recursion going on here, and how it's sort of like it's accumulating the result by in a recursive call returning something and using it in here, using it here. We expect this to return something at some point down the road, and we saw that it will return 0 at the very end. And then that's when the recursion, the way that I like to imagine is the recursion going down stops. The computer then can have 2 complete values to do math with. It does math with that, and then it knows the result of the previous recursive call, and so on and so forth until we get this. Final questions, thoughts? I'll make sure to share these graphics. And
Is that kind of like a stack, or is that not really doing a stack?
What I drew here, what I drew here is basically me trying to represent the stack in a different way from what we were seeing in the code. But yes, this is all happening on the call stack. Other questions? So what I want you to do, actually, I guess what I want to encourage is go to coding.js and solve the recursive questions. The ones we talked about, let me share this here in the chat. These recursive questions are great for practicing this, what we were talking about today. The first one is like factorial, which is basically the same thing that we just did with, it's just that we were doing it adding numbers. Now you need to multiply them. So it's very similar to that, doing the factorial. And there are others interesting ones. Well, Fibonacci bunny ears is interesting. Actually, not this one, but all of these are good. Count high, I think, is good. You know, using recursion to count how many highs do you see, for instance, on a string. So all these will help you get better at recursion. And I think these are, what I like about this is that it starts simple and it starts to get a little bit more gradually, very gradually increasing in complexity. But I think it's gradual in a way that it's not too hard to progress. Cool. So that is all I have for today. I'll make sure to also, upload the recording. But anything else anyone wants to add? Any questions? Well, I hope everyone, say that again, Jonathan?
Thank you.
Yep, you're welcome. So I hope everyone has a good weekend. Excited to see your projects on Saturday. Yeah, and I'll see you all Saturday morning.
Definitely.
Good night,
Thank
everyone.
you so much.
You're welcome. Bye. Oh, Jonathan and Savita, I think you guys are staying with me. Hello.
Hey, good night, guys.
Hi, Dessa.
Hey, Savita.
What? Okay.
Oh,
I'm
wait.
gonna use the restroom really quickly. I'll be back.
Okay.
Okay. Wait, Savita, this is the time you were talking about meeting with Aleo?
Yeah, but it's fine. We can talk about what we wanted to talk about first, and then Alejo and I can go over what I wanted help with.
Okay.
Is that okay?
Yeah, that's okay. Or yeah, because it's Wednesday. Do you want to just go over with why don't you just take this time with Aleo, and then on the weekend, you and I and Aleo can circle back to talk through what the next 30 days can look like for you.
Okay.
Does that sound good?
Yeah.
All right. Okay.
Okay.
All right. Bye-bye.
Good night.
Good night.
Hi.
There's nobody here.
Oh, we
Nobody
not
here.
good?
Hello.
Oh, the check-in. You guys are coming back for the check-in?
Yeah, we forgot about it.
Okay.
You guys were just hanging around in the room.
Yeah.
Cool.
Checking is done already?
Yep.
Okay. I'll see you guys
Oh.
tomorrow then.
Bye,
Or
guys.
Saturday.
See you Saturday. Bye.
Good night.
Good night.
Oh, that's all left?
Yes. You can stop sharing your screen.
Oh, yeah. Before I reveal anything inappropriate.